person has been speaking, Dr. Susan Ustin. If you don't know her, she's our interim director of the Muir Institute. She's also the director of Sea Stars and is a distinguished professor emeritus and keeps trying to retire, and we keep not letting her do it. And she has really done a fantastic job in the last year or so with the John Muir Institute. She's got 35 years of experience working with satellites and airborne Earth observing remote sensing programs, and tons of experience in big data and remote imaging and species mapping and development of methods for quantifying canopy and soil water chemistry. And she's led a bunch of NASA satellite proposals throughout for flying spectrometers in space. She's got tons of awards, a whole bucket of awards, and has been awarded an honorary doctorate from the University of Zurich in 2010. She also manages the UC Davis Space Grant through NASA and Cagle through USGS. So she is going to get us started. And I also want to, before I forget, once more thank Diane Kruger, who has really been a driving force behind this and has been your biggest cheerleaders behind the scenes, and someone who has really big time made sure that money was available from the Steingler family. These are Steingler family funds for environmental research and science and education. And we also want to thank that family and that foundation for their help. So Susan, without further ado.
Well, thank you. You probably spoke for longer about me than I have to say about everybody else. So it's a little bit silly. Anyway, I wanted to just say congratulations to all of you for all of the fine work that you've done. We're really excited about being able to have graduate scholars in this program. This is the third year of the program, I believe. And we've been, we feel like it's really important, and we're very excited about all of the work that you've done and all of the things that, well, Sarah Oktay should have get a big hand for all of the work that she's done for sure, and in selecting you for the award, we're just super excited about it, and we're confident you guys are going to go on and have great careers in so many different areas of environmental science that we're very happy that we've been able to work with you. So that's really what I had to say. Was not as long as the introduction, but it was really important for me to be able to say to you that how much we are excited about students and you guys learning and starting out, because you never know, what you're going to do exactly when you get finished with your PhD, and how your careers are going to go. They're going to go all different ways, and there's lots of things that you're just going to have to take the ups and downs as they come and make the best of it. And that's what you're doing now, and that's why you're going to be successful in the future. So, in spite of COVID.
Thank you. That was beautifully done. Appreciate it, Susan. Well, we'll get started, and each person will be sharing their slides. The first person is going to be Bernardo Bastien in environmental science and policy. The title of his original research was Meta-analysis of Global Ecosystem Services Valuation for Climate Policy Analysis. He's published the article Use and Non-Use Value of Nature and the Lost Cost of Carbon in Nature Sustainability in September 2020.
Thank you. I'm glad you said that the original title was this, because I was like, oh my God, what if it changed? But I guess that's part of the research, no? Just like of course, like giving like a planning and giving all you have, but also like being able to change directions if necessary. But okay, this is I haven't really changed that much. So yeah. I'm going to tell you about the meta-analysis of Global Ecosystem Services Valuation for Climate Policy Analysis, a little bit about what's going on here. So a bit of the motivation is, well, we all know that nature is deteriorating worldwide. Here is an example of some recent metrics of what is happening with natural global ecosystems in terms of its extent, functioning, and species extinction. And also, we know about the drivers, right? That land use change and direct exploitation is causing these declines in nature, but also climate change, which is the focus of my research here. And yeah, like not also is like a current driver, but it's also expected to get worse, no, in the future. For example, at 3 degrees of warming, some studies expect that from 10 to 40% of global terrestrial vegetation will be severely disrupted, and a considerable percentage of species will be at risk of extinction. So this is somehow well understood, but also we don't really know what are the implications for human welfare. Like, how is this going to be reflected in social well-being? So this is kind of like the motivation behind. And when I say how this is reflected in human welfare, there are many lenses to study this. No, one of it is the ecosystem services framework, and the values that we find in nature in terms of use values on one side, like direct use values, for example, like eating fish or hiking, and all the way to the other side, no, non-use values, like the simple like existence value of nature, knowing that the natural ecosystems exist. So I'm using this framework of use and non-use values, and I'm trying to approach this question of the meta-analysis of global ecosystem services for climate policy analysis with two parallel questions. On one side, how large are the climate impacts on, or how large are the ecosystem impacts on social welfare? And on the other side, how these ecosystem services, how can you kind of combine this approach, how to include these estimates of ecosystem services valuation in climate policy analysis? So these are like kind of the two questions. This was the proposed plan on September 2019 when I was kind of figuring out what exactly I wanted to do for the rest of the PhD, and when I proposed this for this fellowship. And yeah, so far the plan is going good. I mean, on the right side, like I can say that I finished like this first stage of this like coupling, no, ecosystem services and climate policy analysis, which yeah, as Sarah said, it crystallized into a paper recently, use and non-use values of nature and the social cost of carbon, which main like result. I mean, one of the graphs I want to show you here, one of the main like graphs that it's showing the results, which is basically, here is the y-axis is what is the optimal carbon tax, what is the social cost of carbon, like the real climate impacts or the impacts of an additional ton of CO2 emitted to the atmosphere throughout each year, and what is going to be the impacts to the society. So here the dotted line here was like the classical or the standard approach that only takes into account climate impacts, economic impacts in the broad sense of the word, in terms of all the climate impacts on the economy and how that damages society's welfare. And here the green line is how does it looks if we include use and non-use values, if we take into account these values to calculate the social cost of carbon or the optimal carbon tax. So yeah, a big difference, like really, if we were to value carbon emissions, taking into account use and non-use values of nature compared with taking into account only economic impacts, we see that this approach give us like a cost 5 times higher than the standard approach. So this is like one of the ways to see this. So on the other side, I'm doing a meta-analysis of a database of ecosystem services that we are partnering with Equilibrium Economics, a consulting firm, that collected 900 individual scientific articles or studies, and they created like this database in Excel. So basically what we're doing is, so what I've been doing in these years is like getting the geographic boundaries of these 900 studies and complementing this data set of, well, not only what is the ecosystem service within this, but also what are other socioeconomic variables as accessibility to cities or the GDP per capita in these regions, population density, to try to see what are the covariates of the ecosystem services value in these places. And also, I have retrieved other climatic or ecological variables like plant functional traits or climatic groups to try to understand how does the value of ecosystem services changes with these socioeconomic and ecological variables. So here the work is not finished yet. Here you can see what are the studies and what kind of ecosystem services do they provide. Here you can see how are these values of ecosystem services distributed across land cover, for example, or like ecosystems like forest, grasslands. So yeah, these are just some examples. And the future steps is to finish this meta-analysis and to integrate it with our work in climate policy analysis. So yeah, thank you very much.
Wow, that was great. Very well organized, Bernie. Thank you so much. We have time for a couple of questions. After each talk, we'll leave it open. That was fantastic. That was a lot. That is a lot and was a lot of work.
Thank you. Thank you. I hope I explain it clear. But yeah.
It made sense to me. Anybody have any quick questions for Bernie before we go on to the next person? If you think of other things too, we can give us a moment at the end. That is a lot to absorb. Okay, I'm looking for virtual hands. You can always throw something into the chat. It's excellent work, Bernie. Are you thinking that you'll have you're on course for your PhD? And do you think you have another paper? Oh, Brandy's got a question. Good for you, Brandy.
Yeah, I'm just wondering, do you have any plans for how to apply this to like get it to policymakers and make it functional in the real world, if that makes sense?
Yeah, I think I still need to think about that. I honestly, I would really like to do that, because as much as we want to say like, oh yeah, the social cost of carbon, optimal carbon tax, like this is like has a direct policy, but it's still a lot in academia. Like, I mean, you contribute in terms of, okay, there's evidence that actually carbon is causing more damage than we thought before. So in that sense, I kind of like think that in that way, my work is contributing to that. But yeah, I would love to see how to really make it a difference into climate policy. Thanks, Randy, for the question.
Yeah, that was an excellent question. Any other questions? I can see a lot of international use for this. Nope, I don't see. Susan, did you have any? Nope, you're good. All righty. Excellent job, Bernie. That's a lot of information in a small.
Oh, you're muted.
Thank you. Our next speaker is Alex Cagle, Energy Grad Group and Department of Land, Air, and Water Resources. And the previous title for his work was Quantifying Environmental Effects and Co-Benefits of Floating Photovoltaic Systems to Reduce Renewable Energy Land Use Conflicts, Change, and Conserve Fresh Water in California. He's published in Sustainability, presented virtually at AGU in December, and just recently co-convened a session at the European Geosciences General Assembly in April. So without further ado, take it away, Alex.
Awesome. Thanks, Sarah. All right. All right. So it's hard to follow Bernie. He's fantastic. I think I have a couple more fun, fluffy pictures of little river animals, but we'll see how it goes. So hello, everyone, and thank you for having me today. Yeah, my name's Alex. I'm a third-year PhD in the Energy Grad Group. I'm researching under Dr. Rebecca Hernandez and LAWR. And my research focuses broadly on the minimization of land use and land cover change associated with solar energy development. And today I'm going to be talking about the research I did over the last year as a JMIE graduate fellow. And it's going to focus specifically on land sparing and environmental implications of floating solar photovoltaics. So before we talk about land sparing and FPV or floating solar photovoltaics, we have to kind of put it in context as why it's a really large emerging deal. So solar is growing at a very rapid rate, as most are aware. It's averaging actually 42% annual growth, which is unbelievable over the past decade. And so this, coupled with a rise in energy demand, is causing energy sprawl to be the predominant cause of land use change in the United States by 2040. And so in the face of looming land scarcity, this rapid growth of specifically utility scale solar is creating growing tensions with alternative land uses, such as agriculture, wildlife conservation, and urban development. And so a perfect example of this is the solar array in this top right corner, figure A here, which is a 16 megawatt array surrounded by agricultural fields. And this is actually the array here in Davis. So right in our backyard, we have a great example of what could be some growing tensions. And so to address these pressing land concerns, it's critical to develop co-location strategies specifically for solar and create techno-ecological synergies between solar and the surrounding ecosystems and ecosystem services. And so one example that is gaining some traction is floating solar photovoltaics. And so this is where I really focused a lot of my research during the past year as a fellow, and specifically on first quantifying the spatial characteristics of FPVs in the United States, the hosting water bodies that they were sitting atop of, and then the technical parameters of these systems and how that compared to ground mounted systems. And so to do this, we studied 4 FPVs in the US that ranged in water body parameters, so size, surface area, depth, technical PV parameters, and then climatic and geographic regions. And so this can kind of be seen on the figure on the farthest right. This study encapsulated 2 studies in California, 1 site in Colorado, and then 1 in Orlando. And so what we found here, just trying to wrap it up quickly, is that when we compared it to ground-mounted solar, there's a huge land-sparing benefit to just putting PV on water. So just per rated capacity, if you rate water surface area and terrestrial land area in the same way, you were generating there was as much capacity in 1 meter of floating solar arrays as there would be for 2.7 meters of traditional utility scale mounted systems. And so this isn't just the panel area itself or the cell area. This isn't taking into account the direct land associated with it. So if you look at the picture on the right here, this is actually the first floating solar array in the world. It's at Farniente Winery in Napa, California, which is in our study. And then they also have an immediate ground mounted array. And so if you look closely, you can see the spacing is a lot different. They're a lot more concentrated per area, and there's a lack of service roads and different types of auxiliary infrastructure around it. And so that's just for rated capacity. And then when we actually took the generation data from this floating solar array, we found that it was still on a generation basis, generating as much energy on 1 meter of the array compared to 2.3 meters of your traditional utility scale energy. And so we took these results and we created standardized metrics for talking about spatial attributes of floating solar. So water surface transformation and water surface use efficiency, which are both terms for generation and capacity weighted spatial attributes. And these metrics have already been picked up by some international PV conferences to talk about future FPV projects and the spatial attributes associated with them, which is pretty interesting. And so, like Sarah mentioned, we were able to publish that in Sustainability, not Nature Sustainability, just throwing that out there, but in September as well. And so after that, it was also a literature review. And so we identified a lot of holes in the literature itself on quantifiable and empirical data. And so we are currently embarked in a 2-year field study across the United States with 2 sites in the Napa-Sonoma region and then 2 sites in the Orlando, Florida region, where we're measuring water quality implications, biodiversity implications, and performance implications of floating solar arrays. And so we're doing this in a couple different manners. So the current testing methodology is for the water quality side, we're taking 15 different samples per pond, 8 of which are going to be on the floating solar array itself, 4 randomized locations in the middle, 1 per each cardinal edge of the array, and then 3 in the open body of water, and then 4 on the shore. So we get a really well-rounded picture of what's going on. We're measuring for your typical water quality parameters like pH, dissolved oxygen, turbidity, conductivity. And then we're also measuring for chlorophyll A and phycocyanin densities so that we can tell what impact FPVs might be having on algal growths and harmful algal blooms in these bodies of water. And so we've got some fun pictures here. This is my colleague Jocelyn last week, actually, on an array in Florida. We were down there taking some of our second groupings of samples. And then the top left is my associate Sean and I doing DibNet samplings for invertebrates. And so some initial results real quick. There's major avian interactions with the FPV infrastructure. Specifically, water birds are resting and feeding off of the panels. And so some of this behavior, especially for herons, was really unanticipated. So we're really looking forward to increased avian surveys. And then we're also finding giant river otters, specifically in Florida, are utilizing the floating solar for protection and shade. And this is a very novel interaction that we were not expecting. So we're really looking forward to seeing where this goes in the next 2 years. And then also perhaps the most unique finding was we're finding 10 to 12 inch dead fish on the array. And we actually caught on camera 2 ospreys interacting in the air about 70 to 80 feet above the array and throwing fish and rodents at the array. Not intentionally, but just as a product of their natural interactions. And so there's also a certain amount of damage to these panels. And so there's some interesting interactions that we're looking to explore there. And then finally, we're seeing that when there's a lot of aquatic vegetation, there's, I don't want to say statistically significant because we're only a quarter of the way through the studies, but seems to be a trend to lower chlorophyll and phycocyanin under these FPV arrays, which is really telling. And then so future research, we're continuing this for the next 1.5 years at these 4 sites in America, and we're looking to extend these methodologies to colleagues in Europe, specifically England, at this floating solar array in the northwest of England, and creating a more robust knowledge set on the actual implications of floating solar photovoltaics. And so I just wanted to say thank you to the John Muir Institute, through which not only was I able to publish a publication, which is a great goal of mine, but also it's been able to create a more robust testing situation for this current project that I'm on. So it's been really beneficial. And yeah, thank you for having me. And I'm looking forward to fielding more questions.
That's excellent, Alex. Thank you. Okay, do we have any questions? Either put your hand, yeah, big hand, round of applause. Feel free to put a question in the chat, raise your hand, or just blurt it out. Susan's got one.
Well, I know you're interested in the environmental impacts of these arrays, and I wondered if are you doing things like measuring water temperatures, around the arrays, or other kinds of things to document what the impact was?
Yeah, definitely, Susan. That's a great question, and I actually cut that out for time. But one of the things we were able to deploy because of the fellowship is long-term water temperature sensors that are hanging. They're suspended under the FPV itself at 4 different locations, and then we have an open body water temperature reading that's taking measurements every 15 minutes across the course of the 2 years. So we're able to really line up those trends with the seasonal studies that we're doing.
Okay, that's great.
Could actually lower blue-green algae outbreaks. There are some positives from the shading. More questions? Majdi has his hand up. Good for you, Majdi.
Yeah, thank you, Alex. A question with drought and water being now on everybody's mind. Have you done any evaporation assessment and comparison? See how the shading effect can be a positive thing to photovoltaics in terms of reducing evaporation and water loss during hot summer seasons?
Yeah, definitely. That's a great question. And so I did a little bit of previous work on estimating evaporative losses for FPV compared to traditional shade covers. That was prior to this project. And then one of the final steps for this multi-year research is doing more of a site-specific evaporative estimate for the FPV, because there's obviously some differences where it's not directly covering. There's still holes where different radiation gets in and evaporation can happen. So that's definitely on the forefront for this second half of the project. That's a great question.
Do we have any other questions? As someone who's lived by the seashore and watched millions of shorebirds, you're going to have to watch out for cormorants and seagulls dropping crabs. And because they do deliberately drop those on rocks on the seashore to open them. So you might have to have netting above them to catch random fish and crabs. Those are the cormorants are a big problem for ocean deployed and lake deployed sensors. Cool. Anything else? It's excellent. You guys are so talented. Okay, I'm going to go ahead and move on to Emily McGlynn. Is with the Agricultural and Resources Economics Division. She's got an excellent, very topical talk and research on Virtuous or Vicious empirical analysis of wood product demand and U.S. forest carbon storage, which is really in the news quite a bit. So thank you so much for being here, Emily. Take it away. We can't hear you, Emily. You're not muted on my side, but you're muted on yours. Try it then. Don't panic. You might have to go with no headphone. We can see your slideshow. We just can't hear you. I would try unplugging. You want to try saying something? We can see it. We just can't hear you. Yeah, still nothing. I can go ahead and skip to the next one if you want to try to figure out stuff. Poor Emily, it worked perfectly 2 seconds ago.
It's the trouble with live demonstrations.
Yep. Yeah, all of them jumped on early and practiced all of their talks. Emily, I'm fine with going on to the next person, coming back to you. Would that make you feel better while you try to figure it out?
Yeah, maybe if it worked before, you could restart your computer and while the next presentation, and then you'll be okay to come back.
Oh,
Is there any chance that worked?
that did. I'm so excited to hear you. No, it did. We can hear you.
Anything?
Yes.
Yeah, we hear you.
Yes.
Oh, really? Okay.
Yep.
I don't know what I did. I like changed. I just changed it around several times back and forth. I guess eventually that worked. Sorry about that. I've been doing a lot of recording, and I guess I screwed something up. Okay. Okay, so I'm going to talk about the project that I had originally proposed for my John Muir fellowship proposal, and it's actually been the project that I've made the least amount of progress on over the past year. I've made a lot of progress on other projects, but this is a project that I feel really stubbornly about needing to answer, and the John Muir Fellowship was really useful in unlocking access to a really important data set that I just was able to purchase a couple months ago. I now have that data in hand, and as soon as I get some free time, I'll be able to turn back to this question. But I'll talk about what I'm trying to do here. My main research question is, what is the effect of a bioenergy demand shock on the amount of carbon stored in United States forests? And just for anyone who is not familiar, bioenergy is any type of fuel. It could be liquid, it could be electricity, it could be solid, anything that's derived from recently living plant matter. And so I'm particularly interested in wood-based bioenergy and how it impacts the land carbon cycle in the United States. So just to illustrate what exactly do I mean by a bioenergy demand shock, let's just pretend that we're dealing with this standing forest here somewhere in the United States. We have lots of nice trees growing, and they remove CO2 from the atmosphere, storing it as long carbon chains for decades to centuries. And now we have this bioenergy facility that wants to create electricity by burning biomass. So that the entry of that biopower plant is going to cause some harvesting of trees around the forest, and then burn it, and then release that previously stored carbon as CO2. But the demand created by that biopower facility for wood could increase the value of forest land for landowners, causing them to switch land use from agriculture to forestry. So we might have a larger forest area than we would have had without the biopower plant. And that demand shock may also encourage management changes by both new forest managers and existing forest managers to plant more densely, or use more fertilizer, or change tree species, which can also increase the amount of trees that we have on the landscape, and the rate at which trees are taking up CO2 from the atmosphere. And so on balance, what I want to understand is, what is the difference between the amount of carbon that is being stored on the landscape over time in this non-bioenergy case, compared to, on balance, accounting for all the economic responses happening on the landscape in this bioenergy demand shock case? What's happening to the forest carbon stock between those two scenarios? And this is really important because forests are projected to be a really important component of US greenhouse gas emissions. I was a co-author on the US mid-century strategy for decarbonization, and we showed that this forest land sink, as it's called, could have to offset up to half of US 2050 greenhouse gas emissions, particularly under a scenario where we have limited access to engineered CO2 removal technologies. However, these scenarios also require really large increases in the amount of bioenergy that's used, particularly in industries where electrification is difficult, heavy-duty vehicles, heavy industry, and aviation being sectors that are likely to use a lot of bioenergy. And so to understand the total cost of decarbonization, of the economy, we want to understand, are these two strategies, both bioenergy use and increasing the amount of carbon stored in forests, are those two things going to work together? Will they be complements, or will they be in competition with one another, which would drive up the costs of decarbonization? And there's a lot of structural dynamic optimization models that look exactly at this question. They're finding the optimal pathway for decarbonization across the economy, accounting for market interactions. But as any economist knows, it's often the case that the economy does not work the way an optimization model might predict, and there's a lot of inefficiencies in these markets that might cause the dynamics between bioenergy demand and forest carbon stocks to be quite different than what we would predict under a dynamic optimization model. So we want to know, what does the data say? How can we use a reduced form econometric setting to really understand in the past, what has the effect of biomass demand shocks had on surrounding forest carbon stocks? So I'm looking to try to answer this question from a completely empirical perspective. And the natural experiment that I am proposing in order to do this is to use historical pulp mill entry as a natural experiment to look at what are forest carbon stocks both before and after the pulp mill enters a given region, and what are forest carbon stocks looking like both within the supply region of the pulp mill and outside the supply region of the new pulp mill. So looking at those different counterfactuals, we can try to identify the effect of pulp mill entry, which I argue can be used as a proxy for what it would be like for a bioenergy demand shock to occur in a very localized region of the forest. And pulp mills are a good proxy for the bioenergy demand shock because as this figure shows, pulp mills are really large. They're some of the largest timber facilities in all of harvested wood products, particularly compared to smaller scale facilities like lumber and pellet mills. And the other thing is that these pulp mills are constructed to last for decades. So we can hope that they will represent to any landowner a really long-term demand shock for wood in the region. And that's what we want to understand for my research question. We want to understand what would the effect of a bioenergy policy shock be. And so this localized pulp shock might give us a good proxy for that long-term policy shock. Okay, so I don't think I want to spend too much time on identification strategy unless people really want to talk about it. This is kind of, you know, what the economists would spend a lot of time talking about. But as I stated before, I want to use these supply regions of a newly entered pulp mill to identify the effect, how our forest carbon stock changes inside the supply region of the entered pulp mill compared to forest carbon stocks outside the supply region. And I have to be able to control for other existing mills in the region, which will create these kind of different polygons of competitive regions. So having to control for all of those factors in this analysis as well. So this is the kind of basic reduced form model that I'm working on right now, using carbon stocks as the dependent variable. And the main things I'm interested in is being the presence of being in a treatment region of a newly entered pulp mill, as well as its interactions with a number of control variables that we want to be able to look at how those things intersect with the presence of being in a treatment region. And so the main reason why it's been tough to make progress on this project is because the data requirements are prohibitive. This is the data set that I just recently have been able to get access to. It was quite expensive. I used all of my John Muir money to purchase it. And I also had 2 other researchers from Princeton and the Nature Conservancy cost sharing with me. So we're all sharing that data set. So it was the funding was very useful for that reason. And now I am also working on a second critical data piece with researchers at Boston University, developing high spatial resolution and annual forest biomass maps, because this is critically the dependent variable of interest in this analysis. But I can get started now that I have my pulp mill entry data set, because the plan is to, in the interim, use what some people here are probably familiar with, forest inventory and analysis plots, to at least get a selection of observations inside and outside areas of pulp mill entry. So I'm probably over time. I'll stop there, and I'm happy to answer any questions.
Wow, that's awesome. We already have a question from Brandy. I'm interested in what you talked about with landowners choosing to change land use to forestry when bioenergy plants show up, and how this might relate to fire and carbon consequences of wildfire, but I'm not super informed about the balance of carbon. Me too, Brandy. Sequestration with fires and land use change. Have you considered what effect this might have on your system?
Yeah, I'm focused primarily, and the pulp mill data set that I'm using is in the southeastern United States, where at least to date, the wildfire risk has not been as severe as it is here in California. So I have not, that's not been a major concern for my setup, but it's correct that I do need to be able to control for both natural and anthropogenic disturbances in the forest. So for example, natural disturbances would need to be netted out of the analysis because there could be some endogeneity there of pulp mills choosing to locate in areas where you're less likely to have natural disturbance. Yeah, so definitely needing to at least have a handle on where natural disturbances are happening.
That was a great question. Other questions?
Hi, Emily.
Hey, Xiao.
Go ahead, Xiao.
Have you tried the continuous vegetation fields data from the NASA? They have very high resolution of forest coverage data. Is that not high enough for you, or?
No, I'm sure that resolution is fine. The big barrier I have is that I need like 40 years worth of historical data. And that's where I would love to hear if anyone has come across that. 40 years of carbon stock data. And we had, so the folks that I've been talking with at Boston University, Ale Bacchini, we've kind of come up with a proposal for how we want to do that, but it's again requiring funding, so and quite a lot of funding. So we're working on fundraising for that. So for the time being, we're probably limited to the FIA data, which I think can get us a good way to starting to answer some of these questions. But it's true that right now there's so much information coming out, you know, spatially explicit carbon data, that yeah, for people that don't need such a long time series, there's a lot of resources out there now.
Yeah, thanks.
Susan has a question.
I just wanted to ask you if do you think that the ecological damage is mostly from siting the pulp mill in the forest, or is it from the removal of the trees, or is it the secondary contaminants that the pulp mill, you know, the effluent from the pulp mill
Yeah, that's a really good question. I have not thought about, I've only been considering right now the impacts of harvesting to supply the pulp mill. I haven't been thinking about effects of, you know, like criteria air pollutants that could have an impact on like forest growth rates. It does make me feel like I'd want to control for like distance to pulp mill. I already have to control for distance to pulp mill because that's going to impact the mill's willingness to pay for any wood that they're purchasing. But it could also be impacting tree growth rates. I don't know how big of a confounding factor that would be. That's a great point.
Some of the things they do, like bleaching the pulp, right, to make paper and things, has a lot of contaminants that get released in the water as well.
Totally. Yeah, maybe controlling for downstream watershed, you know, maybe something like that would be important to do.
Yeah, well, there's always, that's the thing, is once you start on these questions, there's always more questions that come out of it.
Lots of good research.
Yeah, that's excellent. That's very true. Any other questions?
Who sells these?
Emily is asking.
Oh, sorry.
Sorry, go ahead, Bernie.
No, I mean, it sounds really interesting. Just curious, like who sells these data?
The data set I just bought was from, oh God, which group did I end up going with? I was originally thinking I would get it from Forest, but it was RISI. So RISI is like the main pulp and paper consulting firm in the world. I think they're originally based in Norway. But they're the only place I could find that has like 4 decades worth of pulp mill operational data for the US.
It's a good.
And between the time when I first realized that this is the data set I wanted to when I got the data set in hand was a year and a half. So from like funding and negotiating the rights to the data and negotiating with RISI, like what exact data set they could give me, and them like pulling the data, like it took so much longer than I ever could have imagined. So just if anyone else feels bad about how long their research is taking, hopefully that makes you feel a little bit better.
Way to go to be optimistic for others. I really like how you guys support each other, and I'm sorry we weren't able to do more of that this year, but that's great. That's we also had the other Emily had a great comment that with these mega fires, it's hard to parse out, you know, natural versus anthropogenic, you know, and disturbances because they have a little bit of both. Okay, anybody else? We'll move on to Hannah. I don't see any other hands up. We'll might have a little bit of free time at the end too. And hopefully we can do a couple of coffee clutches virtually or in person this the rest of the year to chat about some of this. You guys are really helpful to each other. That's my opinion, just hearing some of your questions. So the next person is going to be Hannah Safford. She's works with civil and environmental engineering. Her work is entitled originally Closing the Water Cycle, Rapid Virus Monitoring to Enable Direct Potable Water Reuse. She's been exploring the policy implications of this research through 2 projects, one examining how continuous monitoring of waterborne viruses can close the water cycle by enabling safe reuse of wastewater for potable purposes, and one project examining how tracking viruses in sewage can help inform public health response to pandemics like COVID-19. That's a really big thing from one side of the coast to the other to actually get an idea of the population burden of disease through sewage treatment. She was also a member of Policy Science Advisory Committees for Secretary Peter Buttigieg's 2020 presidential campaign and later for the successful 2020 campaign of President Joe Biden. Take it away, Hannah.
Okay. You guys can see this, yeah? Okay, I've retitled my presentation to be called Monitoring Viruses in Wastewater is Even More Useful Than I Thought. So like Sarah mentioned, when I started my PhD, I was always interested in implications of water shortages and how advanced water treatment and reuse can help address those shortages, especially salient right now as California continues to be going through a pretty epic drought. In California and elsewhere across the country, we do a fair amount of water reuse, not as much as we could, but we do it. There's a lot of, the two biggest kinds of reuse that we do is we either do direct non-potable reuse, so direct meaning that you take your water and you put it directly on something, non-potable meaning, of course, that's not suitable for drinking purposes. So an example like that is water reuse for crop irrigation. We also do indirect potable reuse, which is something like groundwater recharge, aquifer recharge, where we take treated wastewater that's not suitable for drinking, we put it underground, and over time, it kind of naturally gets treated in the same just processes through the water cycle, and then we eventually can extract it and use it for potable purposes. Of course, we'd like to be able to combine these two things into direct potable water reuse. So the idea of closing the water cycle and going directly from toilet to tap, from wastewater to drinking water. That'd be a whole lot more efficient, it'd be more time efficient because you wouldn't have to wait for years and years for the natural water cycle to do its thing. And you also wouldn't have the huge energy and transportation costs that come with transporting water from one big centralized wastewater treatment plant and then to one big centralized drinking water treatment plant. You could do things like enabling building scale direct potable water reuse. You could have a community that's able to close the water cycle. There's a lot of potential for this kind of distributed water reuse if you can close that water gap. So that's been a driving overall motivation of my PhD. If you're thinking about doing any kind of water treatment or water reuse, there's two classes of hazards you have to deal with. There's chemical hazards and there's microbial hazards. And I'm not going to tackle all of them. So I am focused on microbial hazards. And in that class of microbial hazards, I'm focused on viruses. The project that I started working on was focused on doing quick and reliable monitoring for viruses. If you think about the types of water quality parameters that we typically monitor for, those include things like pH and turbidity and salinity, all things that you can kind of just stick a probe into the water and you can get these real-time measurements, right? So if you imagine going from wastewater to drinking water, it's really important to know in near real time whether you have any kind of process failure, because you don't have that much time to correct the process failure. If you're just treating wastewater and then discharging it to the ocean and you have a process failure, that's not great, but at least like it's not going directly into people's glasses or into people's showers. So it's not as catastrophic as it might be if you were doing the direct potable water reuse. So again, we have some kinds of online real-time measurements when it comes to physical and chemical water quality parameters, but we have nothing like that when it comes to microbial water quality indicators. So measuring the types of bacteria, protozoa, and viruses that might be present in wastewater and drinking water that we care about. Typically, to measure microbial hazards, you do either like molecular analysis or you just put a lot of water on a plate and you see what grows. And both of those things are quite labor intensive and take a lot of time. And you can only really get so much spatial, temporal resolution rather. We talked about that, we'll skip that. So the technique that I was exploring for applications to microbial monitoring is this thing called flow cytometry. The concept of flow cytometry in a nutshell is that you suck up some of your sample and you use a sheath fluid to focus that sample into a very narrow diameter. That narrow sheath forces all the particles that are in the sample to line up in more or less single file. You can then pass all of those particles through a series of lasers, and based on how they either scatter light when they're hit when they pass through the lasers, or how they light up, how they fluoresce when they pass through the lasers, you can quite quickly get a sense of what each particle is, whether it's a bacterium or a virus or just some piece of crap that's in the water that you don't care about. And you can get those results in a matter of minutes. So the potential for online microbial monitoring through flow cytometry is real. That's an example of a flow cytometer. My plan was, when I applied for the John Muir Fellowship, I had already been working on methods development for microbial monitoring using flow cytometry targeting viruses. And then my application was, I was then going to try and apply this to the Sustainable Wine and Food Processing Center on campus and see if some of those methods could work in practice. Then COVID happened, so then the plan changed, but it turns out that monitoring viruses in wastewater is quite a hugely useful skill when you're in the middle of a global viral pandemic. So my PI and my research group was all focused on sort of health implications associated with wastewater and drinking water and water generally speaking. COVID happened, and within a couple of months, it became clear that one way you could track COVID in a community was by looking at viruses in the wastewater. To give you a better sense of that, let me actually skip that part. So for clinical testing, we're all in Davis, we've all done the saliva test. It's pretty quick, it's pretty easy. For us, it's free. And it's really an important gold standard to determine the infection status of an individual. But when it comes to trying to monitor large scale COVID trends, clinical testing has some drawbacks. I think we all remember, like early in the pandemic, we were way under testing. And so it was very difficult to get a sense of how big the COVID problem was. We solved that problem pretty quickly in Davis, but still it's quite expensive to be doing this, to be doing testing a whole lot of people every week, sometimes multiple times a week, if you're really in the heart of the pandemic. Fortunately, in Davis, we have a funder for Healthy Davis Together, but other communities don't have that. It's invasive in the sense that it's a bit of a headache to have to go to a testing facility. And so many people just won't do it. And there's an opportunity cost, a human opportunity cost to the time that you spend going and getting tested. Like I said, it's time consuming. And it's also biased. Like in Davis, we have asymptomatic testing. So theoretically, we're testing everybody, regardless of whether or not they're showing COVID symptoms. But in reality, the people who show up are people who had just done something that was a little riskier, are people who are experiencing some kinds of symptoms, who maybe think they had a COVID exposure. So it doesn't give you a great picture of how much COVID is really spreading in the community, because you're focused in on the groups of people who either are super motivated to get tested because they're diehard public health advocates, or who have recently engaged in risky behavior and are worried about it. But it turns out that regardless of where you are and what your opinion is about going and getting tested, you still poop. Everybody poops. And if you're infected with COVID-19, if you're infected more specifically with SARS-CoV-2, the virus that causes COVID-19, then you're going to shed some of that virus in your poop. And if we take samples of wastewater from different parts of a community, by tracking the levels of SARS-CoV-2 in the wastewater, we can get a pretty good sense of the extent to which COVID-19 is present in the community. And as we track the levels of SARS-CoV-2 in different parts of the community, we can even zoom in and get a sense on which neighborhoods or which areas of a community are experiencing particularly high COVID burdens. And then you can follow up with those areas, with those communities, with more targeted interventions, such as clinical testing. So it's a nice complement in that way. So briefly, it's a cheaper way to get a lot of data on a community. It's not biased because everybody poops. You're pooping already, and so it doesn't take you additional time. And there's not that much privacy concerns about the data because it's aggregates and naturally aggregated data sets. You don't have to worry about individual testing results being like hacked into, or somebody like being seen going to a testing facility and like, oh, what was that person doing recently? And it's a useful complement to clinical testing. It reinforces the confidence in those clinical trends, And like I mentioned before, it can help you more strategically deploy health resources instead of just trying to blanket an entire community with them, which really may not be feasible from a resources standpoint. So my research group, especially my PI, kind of was made aware early in the pandemic of all of these advantages of wastewater sampling for pandemic public health response. And we initially, and then she needed some help, because if you're a PI, you need a lab monkey, and your lab monkey is typically your PhD student. So she looked at all of her PhD students, and I was the one that was doing viruses in wastewater. So then I became the PhD student who was on this project. Initially, we kind of just proposed it as like a casual thing, like, let's see if we can make this work in our lab. And then it grew really quickly, and to somewhat astonishingly, I mean, we got a lot of funding from Healthy Davis Together. So we got a lot of new equipment that increased our sampling capacity. We had strong buy-in from the campus and from the city. It made news, and now we have this whole dashboard on the Healthy Davis Together website for wastewater testing. I made this map and I wrote this text. And if you go down to the actual website, you'll see a lot of plots, and I make those plots every week. And so in the course of less than a year, we scaled up from just taking one wastewater sample from the UC Davis campus wastewater treatment plant and using this somewhat labor-intensive and time-consuming filtration-based method that took us 2 days to get results. And now we are processing more than 100 wastewater samples every week in-house at our lab, and we get results in less than 24 hours. We deliver those results directly to the Healthy Davis Together program managers, as well as to campus administration. In brief, our workflow looks something like this. We have staff from the public works at the city and from facilities at UC Davis who go out and collect our samples for us. We collect from the UC Davis wastewater treatment plant and the city wastewater treatment plant daily, and we collect from campus sewer shed and the broader Davis sewer shed 3 times a week. It shows up at our lab. We pasteurize it to inactivate the virus without degrading the genetic material. And then we use this kind of like nifty magnetic bead-based method to concentrate the viruses, because we're looking for a very small amount of virus in a relatively large sample. Wastewater is pretty diluted. So we do this concentration process using magnetic beads. We do a similar method to extract the genetic material, and then we run the exact same PCR assay that's being used for saliva tests to see whether or not SARS-CoV-2 is there and in what quantities. Like I said, we're monitoring at a bunch of different scales to inform decision-making at different scales. So in Davis, we monitor first at kind of this regional level. So we have we've divided the city roughly into far west Davis and north Davis, far east Davis, etc. And then we actually subdivide these even more to zoom in on neighborhoods. So we've got each of these regions represents a different sampling location that collects the wastewater from the areas that are outlined by the different colors. And then black is we worked with Deloitte, the consulting company, and they helped us identify neighborhoods that were either at high risk of transmission or particularly vulnerable for COVID, or had high risk of comorbidities. We also targeted a couple of other facilities of interest. So we have one zone that's targeting a part of Davis that includes a senior care facility. We're monitoring upstream and downstream of the school to see how wastewater surveillance can support safe return to school strategies. We are monitoring at a couple of apartment complexes. And I think all in all, we have 24 different locations in the city that we're monitoring at. And then on campus, we are monitoring every single dorm that has residents in it right now. That'll change as we go into fall. We get more more students back on campus, but for the duration of this school year, we've been monitoring twice a week at every single dorm. And when we get a positive, then that can inform targeted messaging to the residents of that dorm that, you know, even if you've gotten tested recently, you may need to go get tested again. It's also an education tool. Like I said, on the Healthy Davis Together website, we have all of our data publicly available, so you can explore kind of the data from the whole time that we've been sampling, as well as you can zoom in on stuff most recently. You can compare the sewer shed data, so the trend in a particular neighborhood, to the trend from the city overall, as evidenced by the wastewater treatment plant. Like I said, I make all of these plots. I do it every week. I also mentioned the targeted communications that we're doing at the dorm level. We can do a similar thing at the city level. So we're integrated with the Yolo County alert system. So if we get a sustained increase in SARS-CoV-2 in a particular neighborhood, we can send text messages to all of the residents of that neighborhood to go get tested, to adhere to hygiene strategies. At the campus, that information is informing planning. So we group dorms into whether there's a low concentration, a moderate concentration, or a high concentration of SARS-CoV-2. When students come back to campus in the fall, we'll continue doing this monitoring to an extent. So you could even envision a world in which you get a positive in a dorm and you can isolate and lock down just that dorm until you test everybody and find the infected individuals, so the rest of campus operations can kind of continue as normal. Some other universities, for instance, the University of Arizona has done a similar thing and it's worked in practice. I'm also working with a stats team at UC Davis to try and relate trends in the SARS-CoV-2 levels in the wastewater to infection data from Healthy Davis Together. That's been done by a number of other researchers at the city scale, but we're doing a pretty novel analysis of trying to compare infection data, like clinical data, to wastewater data at the regional scale and at the neighborhood scale. And then finally, so I thought I could have stopped there, and I thought I would just kind of briefly bring it back around, because the COVID stuff is what I've been doing for the past year, and it is absolutely nothing what I told John Muir Institute that I was going to do. But I still plan to go back to my flow cytometry work as we've established the environmental surveillance program more concretely. I'm getting phased off of that and back into my regular work. I also have a master's student who's now working with me again on the methods development for virus detection through flow cytometry. And I'm coming back into this project now with much better knowledge of the behavior of envelope viruses. SARS-CoV-2 is an envelope virus, and previously I was only working with viruses that are non-enveloped, and so I'm pretty interested to bring some of that new knowledge back and optimize methods for detection of envelope viruses as well as the non-enveloped. All of just the molecular methods, so in reverse transcription, qPCR is a thing that I've been doing. This more kind of accurate type of PCR called digital droplet PCR I've learned how to do, and those are all useful validation mechanisms for virus detection through flow cytometry, so I'm coming back to my project with that. I know a whole lot about how to process a lot of samples every week, and then working with the stats team, I'm learning a lot about statistical analysis of microbial data, which again will be quite useful for going back to methods development and flow cytometry world. And those are all the people who I'm working with. Again, it started as kind of just me and my PI and one staff researcher, and now we have all these people who are working on this project. So it has been quite fascinating to see it evolve. And that's all I got.
Thank you so much. We'll have to hold questions for Hannah because we're running a little short on time. So I'm going to go ahead and jump ahead to the next two. Excellent talk, though. Obviously, super critical and very important, and a good example of what happens in science and research and your PhD program as you end up going places you never thought you'd go. It's fantastic. We'll have a chance at the end of the evening, as it were, for people to ask questions, but I want to go ahead and jump on ahead to Jialing Huang, who's doing a talk tonight on market designs under the Sustainable Groundwater Management Act, and coupling the groundwater cap and trade system, at least in their original work, with banking and borrowing regimes. So Go ahead and take it away.
Thank you, sir. Okay, can everyone see the slides? Okay, great. I'd like to start this presentation by talking about the motivation of my paper. So due to over-exploration and climate change, groundwater overdrought has become very serious concerns all around the world. Groundwater depletion has many negative impacts, such as reducing the in-stream water, seawater intrusion, and deteriorating the water quality. In California, groundwater accounts for 40% of the agricultural supply and is the main source of many domestic use for many communities in the Central Valley. So in recent years, due to the lack of management and a prolonged drought in California, over 3,500 domestic wells went dry. So in response to the problem caused by the groundwater overdraft, the California legislature passed the Sustainable Groundwater Management Act, aka SGMA, in 2014. So there are 515 groundwater basins in California that was classified into 4 categories: high, medium, low, and very low priorities. Although there are only 94 basins fell into the high and medium priority, these basins comprise 98% of groundwater pumping in California. So SGMA requires that the high and medium priority groundwater basins to form a groundwater sustainable agencies, which is GSAs, and develop localized groundwater sustainability plans to restore sustainability by 2014. So in order to achieve sustainability, groundwater basins have to avoid 6 undesirable consequences that are listed here. However, SGMA does not provide any guidance on how groundwater basins can reach the sustainability, and also what management regime they need to adopt to achieve this goal. So all of this motivate this paper to investigate and compare social welfare under different quantity-based regimes. And this paper contributes to the existing literature by introducing cap and trade system with banking and borrowing in groundwater management, and also the model in this paper consider the interactions among heterogeneous farmers. So without going over the model details, this paper comparing the following 5 policies. The first one acts as a benchmark, which is no management. So it literally imposes no restriction on groundwater pumping activities of farmers. So the other 4 policy regimes are under management, which means the total annual pumping allowance are capped for farmers. The first management regime is equal allowance, which is equalize the annual total allowance for farmers to pump water from the groundwater basins. The second one is command and control, which also cap the total amount, but consider the dynamics of groundwater table heights over years. Up to next, we have a cap and trade system, which is farmers are capped with a total amount that they can pump from groundwater. However, they can also trade their pumping permits with other farmers if they want. And finally, we have a policy that is cap and trade system with bank and borrowing provision, which means the farmers can not only trade their pumping permits, but they can also carry the unused permits to the following years. Okay, so my research area is the Fox Canyon Groundwater Management Agency, located in the Ventura County. As I mentioned in previous slides, that there are 6 undesirable consequences. For the purpose of this paper, I simplified the goals to only meet the criteria that avoiding the continuous lowering groundwater table heights. So what that means is at the end of 2014, the groundwater table of a groundwater basin need to reach certain points, which is higher than the initial groundwater table height. So the following 2 slides shows how annual pumping quantities and the groundwater heights change over time under different policies. As we can see from, if there's no management, which is represented by the purple dots, the groundwater quantity stays very high, and the groundwater table level continues to decrease over years. While the other 4 policies, the groundwater heights are restored gradually and hit the final points in 2014. And not only that, I also compared the social welfare, which is measured by the groundwater basin wide farmers' net profits. So the cap and trade controlling command policy improves welfare upon the eco allowance by 1.43%. Control cap and trade system improved the welfare by 4.48% compared to controlling command. And finally, the bank and borrowing pairing with the cap and trade system improved the welfare by 2.68% based on current simulation. Yeah, so yeah, that's it. That's a brief introduction for my research, and I'm happy to take any question at the end.
Thank you, Xiao. That was really great. It's super useful for people to be able to see how policies can change groundwater recovery. We have time for like 1 or 2 questions, if anyone has one. Liza?
I don't know how to raise my hand.
Oh, that's fine. No, that works.
I guess if I'm curious if you've engaged at all with comparing these results to say what have already been published in sort of the draft plans, because my understanding is that at the end of the day, it's, you know, groundwater agencies that are making these decisions. And so have you done any work to say, look at the evidence we found in these regions, or how's that gone?
Yeah, that's very good questions. So so far for groundwater agencies, not all of them adopt the cap and trade, which is the market-based system. So my paper is trying to persuade their policymakers to adopt market-based systems, and also pairing with the market with the bank and borrowing provision that farmers can carry the unused permits over to the next years. So for the example of Fox Canyon, they adopt the cap and trade system, but they haven't adopt the bank and borrowing policies. So I'm trying to like make suggestions to their basin.
Great question. Very cool. I liked how you included the welfare stats too and the economic benefit. Andy, I have time for one more question if anyone has one, and then we'll, Susan, go ahead.
Well, my question was just, has there been any surveys of both the water districts that are having to make these policy changes and or the farming community as to how they're adopting it? Because it's quite an extreme change from current practices, and particularly right now with the drought that we're in. Of course, they want to pump, but then the wells have to keep getting deeper, and it costs more and more to pump. So it's not all like they don't want to do it, but I wondered how much cooperation is happening, or if you have any idea about that.
Yeah, I haven't done survey because due to the COVID pandemic, I cannot go to. I plan to visit those basins, groundwater basins, and really talk with those farmers to see how they would comply with the policy changes. But I see a lot of basins, they are actually just doing a controlled command, which is just cut off the water supplies for the farmers. Which is not very good as from the aspect of an economist. So for those kind of basins, we would propose there to adopt more market-based regions. So some farmers can benefit from exchanging and trading the permits and not using all the water they were allowed. Yeah.
I mean, that's a shift from annual production like tomatoes and melons and things like that to perennial crops. That's really taken over the whole valley. It's got to have a big implication on this.
Yeah, and also my model is also to consider how the land use was changed from the annual crops to perennial crops, and also from low value crops to high value, like from alfalfa and some other low value crops to nuts and the trees.
Yeah.
And Liza, who's going to be our next speaker, had a great point too in the chat, Xiao, about previous Muir Fellow and Linda Mendez from both of Davis have put out papers on how actors are represented in these Sigma governance decisions. That's really helpful. And it's a great segue into our last speaker for the night. I will, don't run away though after Liza, because I want to introduce you to Brandy, Hannah, and Emily Purvis, Hannah Cheney. So we want to give them a chance to speak too. But our last 2020 John Muir Fellow is Liza Wood, Environmental Science and Policy. She did our original research was seeking seed system resilience, network analysis, and interventions of California seed innovation systems. So another really cool policy related project. Take it away.
All right. Okay, we should all be good. And all right, so I'm Liza Wood. I'll try to be brief with my time here. I'm in the graduate group in ecology in the Center for Environmental Policy and Behavior, so more on the social side of things. And what this project has morphed into is pretty close to the original proposal, maybe minus a few words, but looking at the ongoing work of seeking seed system resilience, a network analysis of seed innovation systems. And there are a few challenges facing agriculture that are really kind of the focus of this research. And mainly that's diversity loss, particularly at the genetic level of our agricultural crops, which has occurred through a long history of crop domestication and breeding for desirable traits, where now we have crops that thrive under a really narrow set of conditions that are not as resilient to stressors. And alongside this, climate change is adding additional pressures that make agricultural system resilience even more important. And often state and federal policymakers really like to focus on the farmer. They want to know, how can we get farmers planting more diverse crops? How can we get farmers practicing climate smart agriculture? And this is a lot of what you see in California climate policy. But my work wants to turn attention to more upstream actors in this process. So the things that happen before the farmer is making decisions. And so instead, I look at breeding innovations more broadly that can help address these challenges. And there are two kind of stylized approaches to breeding. The dominant conventional approach is based on sort of this reductionist biotechnological solution that focuses on breeding in new resistances. And alternatively, there are more niche organic-based approaches like participatory breeding, particularly in settings like more diversified management systems that we can just sort of call a more holistic approach. And this research looks at how we might facilitate the growth of this more holistic breeding within organic seed systems specifically. And to do this, this research takes a systems level approach, and what that means is that I start with not the farmer, but the material innovation of the seed. And then I add on a few more layers. And so that means including not just the farmers, but also university researchers, seed companies, and seed advocacy organizations. And then on top of that, I'm interested in the macro level presence of things like infrastructure, markets, and policies that interact with all these decision makers. And together, this whole image really constitutes the seed innovation system. And these sorts of approaches are really critical to understanding how to manage sustainable transitions more broadly. And so it's this system that I'll be focusing on today. And the motivating question here is, how can we support innovation system capacity of organic seed? And I'm focusing on organic because it's not a perfect cure-all for all agricultural challenges, but more often than conventional, like I said in the previous slide, it's these breeding approaches that tend to promote seed that's regionally adapted, considers inputs from farmers, and is usually bred for management in more diverse and agroecological settings. So we have our seed innovation system, and according to theory, as I said, it sort of has these main features. At the macro scale, there's infrastructure, markets, and policies, and at the micro scale, you have actors and their interactions in the form of network structure. And the focus of this work is on the network structure of these interactions. And what theory tells us about these interactions is that they should generally be diverse, connecting different actor types, and well connected with multiple ties. And these are characteristics that also align really well with theories about social ecological network resilience. And so this is sort of the ideal that we have in mind. But often in innovation system studies, these standards are put out there, but not actually tested using network methods. And so the goal of this paper is to relate network interactions to these specific innovation system challenges related to these macro level features of the system to evaluate organic innovation system capacity. And to do that, I am using data from a survey that I've been developing and carrying out with the support of JMIE throughout 2020, and also in collaboration with the Organic Seed Alliance, which surveyed different kinds of stakeholders in the organic seed system. So seed producers, companies, as well as researchers. And I'm working kind of on snowballing out from these original surveys to a second wave to sort of get the complete network. And just to give you a quick sense of the response rate so far, the whole population that was sampled, this will show you basically that the darker colors of a state means that there are just more seed producers there. So you'll see most of the action of seed production is on the West Coast. And surveys are tough. Having an average adjusted response rate of about 32% is pretty good as far as farmer surveys are considered. And basically, if a state is orange or darker, then that means that we have a pretty good representative sample. And just some quick demographics. We're mostly dealing with really small producers. So this is the organic seed sector, which is a small but growing sector, but still is mostly dealing with operations that make under $50,000 a year. And are dealing with a really diverse range of crops. So most of these companies or producers are working in vegetables, but as well as a series of other kinds of crops. So a reminder, the goal of this research is to relate network interactions to these innovation system challenges to evaluate the capacity. And so to do this, To define these challenges, first, I'm relying on this question from the survey that provides kind of this whole suite of challenge lists and asks respondents to gauge how much of a challenge that they are. And you'll see these range from business activities and infrastructure to certification costs and intellectual property management. And what I do is I use kind of a factor analysis to reduce the data into sort of just these 3 big buckets related to these macro level innovation system challenges. And that is how I will be evaluating these sort of innovation system capacity. But that's just the challenges section. As for the network interactions, there's also a survey question that looks at, for your work in seeds, who do you collaborate with? And then there are 4 different kinds of collaboration that I have been able to sort of map onto these actors. And this is just sort of a quick snapshot of the network of the seed system, color coded by the kinds of stakeholder that they are. And it's with these 2 bits of information, the innovation system challenges from the last slide and the network structure here, I can use a network model called an autologistic actor attribute model, which the main crux to get away here is that network models are unique in that they drop typical assumptions of independence, like a lot of, say, standard regression have, and instead explicitly model the interdependence of how network interactions relate to the experience of users in a network. So how can certain interactions reduce experiences of innovation system challenges? But I don't have results yet because networks really rely on having as complete of data as possible. So this last wave of snowball sampling that I'm doing is pretty critical to me, finalizing this network, but I'm getting a lot closer. And really the significance of where I hope this work is going is that it identifies the kinds of network interactions that policies and organizations should foster to reduce innovation system challenges for organic seed. So really focusing on what kinds of connections can help this niche system. And these kinds of policies are usually executed through things like platforms for supporting collaboration, as well as reconfiguring policies to reduce some regulatory and market challenges. So I've spoken to a lot of these folks about really specific things that can be changed within the system. And partnering with the Organic Seed Alliance has been a really cool opportunity because they put out a big report every 5 years that I will be a co-author on, coming out at the end of this year, that works directly both with the stakeholders in this system as well as plays a pretty big role in shaping organic policy. So there's still a lot of work in progress, but it's been really great to sort of work through this with the help of JMIE. And so I will wrap it up there.
That was really nicely done. Thank you, Liza. Very cool. So let's see if we have any questions. Good for you for that. That made a lot of sense to me, which means it was well done because I'm lots of applause. Do we have time for like 1 or 2 questions? And I'd like to introduce our 2021 winners, and then we can put our feet up and everyone that presented can have the congratulatory beverage of their choice. And I love the diversity of all of these projects. I think we did a really good job in picking some really smart people that are doing some really hardcore policy things. Hannah Cheney has a question. What type of innovation barriers is your research looking to eliminate? Do farmer needs factor into these barriers? That's a great question, Hannah.
Yeah, so what I like about this work is that because we're surveying such a range of folks, a lot of seed producers are also farmers. And so a lot of this is like from the perspective of the people who are really in it, what are your challenges and how can we more or less directly address that, whether it's through Organic Seed Alliance's work, or hopefully I'm trying to do this more systems level work. But a lot of it is things like the policies for organic seed are really messy. Like so in the United States, farmers have an exception. They don't have to buy certified organic seed if the variety they want is not available. And so it makes it really hard for seed producers or the organic seed system to really take off because demand is really hard to actually anticipate. But this has been the same in the EU up until just recently, where now they're phasing out this exception and trying to like integrate this into a stricter organic certification rule. And so it's cool to see their conversation, which I imagine is probably 10 to 20 years ahead of ours, and seeing like how they're trying to really support then their organic seed producers, like mostly connecting them to markets, changing these policies to make their markets more consistent. And then there's a whole intellectual property protection challenge that I won't get into, but then it becomes very IP legal heavy very quick, but it's been fun to learn.
That was a great question, Hannah. Any other questions? We have time for, thank you, for one more, and then I'll introduce our new winners. Susan's got one. She's like me. She can't help herself.
Yeah, well, I realize I probably should ask you a question. On these seed sources, do you know how different they are from the regular commercial organic? The commercial crops of the same type. I was wondering. Mainly because everybody's really worried about we're losing all these genes that might be useful under climate change conditions, right? In the future, 100 years from now or something, when our conditions are quite different. And I wondered how different are the varieties that the organic farmers are using compared to the genomes of the more traditional, agricultural ones.
Yeah, and that's a great question. And some of these data are really hard to get. Like when you start trying to track genes through public systems is a totally different fun side project. But I think the key difference is often the conditions under which they're bred. So while I can't tell you explicitly about the genomic makeup, instead of breeding it for, basically a high nitrogen fertilizer input, you're breeding it to work with your crop rotations, you're breeding it to work with your integrated pest management. And so I think the underlying idea is that by breeding it to work in a more sort of agroecological setting, that these sorts of things allow for, or at least are not selecting against, a greater level of allelic diversity. And there's been some really interesting studies that have been working with conventional material that has now been made public, and they're finding that like inadvertently they've sort of lost, say, corn's ability to foster a healthy microbiome in the soil. And so there's sort of evidence on both sides that we're inadvertently just losing a lot of the agroecological qualities that we didn't even know what to look for in conventional breeding. And that's sort of where organic tries to push back, I think, in integrating it into their systems.
Well said. Alrighty, that was a great question, Susan. I don't see any other hands, so I would like to go ahead and give our last three speakers and our 2021 winners of the Muir Institute Graduate Scholars Award, which will be slightly different this year, not just because of COVID, but we're trying to connect it a little closer to our fellows that are our postgrad fellows. But the three winners this year are Hannah Cheney, and Brandy Goss, and Emily Marie Purvis. And I'll have Hannah speak first, and then we'll go to Brandy and then Emily to round us out.
Okay, yeah, thank you everybody for just the wonderful presentations. It's really informative just to hear what you guys are looking into. So yeah, as Dr. Oktay said, my name is Hannah Cheney. I am a master's student in the International Agricultural Development Program. And my program that I'm working with Dr. Abu Najim, who I think I had to hop off this call, is it's taking the sustainable development goals and applying them on more a community level basis and comparing metadata from we're going to do 2 case studies in the Central Valley of California, in Paradise and Clear Lake, which are economically disadvantaged, and we're going to compare some of those specific community level results to kind of the county and state level and national level of the sustainable development goal indicators. And I think this will be important to just develop this policy level framework for the sustainable development goals, because as I stand right now, it's kind of just like vague and really at the national and international levels. And if we can develop a framework that's both generalizable enough to be applied to different case studies, but also specific enough to be of use for the communities that we apply them to and provide some type of tool for policymakers to make decisions. I think it could be really beneficial for policymakers and community decision makers and members alike. But yeah, thank you.
You bet. Thank you. That was well said. Very, very thorough. And congratulations. And let's hope the rest of this year goes a little easier than last year. Brandy, do you mind going next?
Sure. First, I'd like to say that I'm really excited to be a part of this, and I really enjoyed your guys' presentations. Some really cool stuff going on. So I'm Brandy Goss. I am in Dr. Rob Lusardi's lab in the Center for Watershed Sciences, and I work mainly on anadromous salmonids. My master's work will be centered around beaver dam analogs, which are essentially fake beaver dams that are made mostly out of natural materials that it can be installed in places where it's hard to reintroduce beaver or where they've been locally extirpated. So that involves a lot of California. Coincidentally, the fur trade in the 1800s destroyed a lot of beaver, and they're obviously important ecosystem engineers and contribute a lot to the physical and biological diversity we see in a lot of regions. So I'll be using stable isotope analysis to look at reconstructing food webs in traditional stream habitat and in BDAs, and I'll also be piloting a study to see if sulfur isotopes can be used to determine whether endangered coho salmon are using the BDA habitat. And hopefully that can be, if it's successful, later applied to additional ecological studies to see if there are the benefits we think there are going to be for coho salmon compared with traditional stream habitat rearing in the future.
Awesome. That will be fun. We might have to try that out a little at Lassen. Very interesting work. Okay, Emily, you get to play us out, as they say. Emily Purvitz is our last winner for 2021.
Hi, everyone. Yeah, thank you to all the other speakers. Your projects are so cool. I'm also excited to be one of the 2021 fellows. I plan to do a project that looks at the interaction between climate change and subalpine forest vulnerability to bark beetle outbreaks in the Sierra Nevada mountains. I plan to combine both field surveys and aerial imagery collected using drones, and then put the data into a deep machine learning model to be able to scale up forest data collection so that then I can fly the drone over areas where I haven't collected on the ground data and be able to get like a much larger spatial distribution of data. And I plan to look at climate-driven direct, indirect, and interaction effects of mountain pine beetle dynamics. Look at how the dynamics vary with environmental conditions across the landscape, and then see if I can create another model that forecasts mountain pine beetle outbreaks. So stay tuned to see if I accomplish any of these things in the next year.
That's awesome. We can sample some for you too at Lassen. Great. I'm very excited to be working with all three of you throughout the rest of this year. And I'm very proud of everyone that presented today. You're doing excellent work. Please share with me your papers as they come out, your highs, your lows. Make sure to keep, we're still here for you, especially with last year being so crazy. So feel free to use this as a resource. We're available for you at the John Muir Institute. And we want to, ballyhoo your accomplishments on our website and Twitter and Facebook, and make sure the world knows about all your cool stuff. For either Diane or Susan, did you have any final words?
Well, I could just say how impressed I am by everybody. I think you guys have done a terrific job. It's very amazing. All of the diversity of everybody's study they're all fairly unique, and a lot of them look like they're super practical right now. So I just think it's been very exciting, and I certainly look forward to the three of you, the new ones, for equally interesting projects by next year. So that, these things go on, and you may return back to some of this work that you've done as a graduate student 20 years from now. You never know. how they're going to work out. So, you know, just because you change and you end up in a kind of different project and you started out with is not a problem. You just follow the research where it goes.
Absolutely.
I also wanted to say thank you to all of you. I know it's been a tough year to meet and bond together in presence with each other. So I hope that you continue a relationship with us. I was writing to Hannah that I'm going to be reaching out to all of you at some point so that we can continue putting some of your work on our website or newsletters, but really continue the family with us together. Even if you're done with your year, it doesn't mean you're done with what we're trying to do. And you can mentor students to come. We started this 3-4 years ago. It was a dream of mine to launch this. And I found a way to do it. It took a year. And then Sarah Oktay knocked it out of the park. She and I met before she even came to California. And I told her this vision. And here's the things that we need to really put it together. So I also want to give maybe a shout out and accolades to Sarah. Thank you.
Thanks. Thank you, Diane. It's been a lot of fun.
We're not at a party and, you know.
I
So
know.
we're going to do it next year and you're all invited and to do snippets and where you're continuing on your journey. I am doing something for a program review and it's metrics and they tell me to do all the finances and I'm doing that, but it's like, it doesn't measure the impact of something like the Scholars Program. So I'm going to be bothering you tomorrow, Sarah, just to say, how can we put in writing bullets on the impact? Because this is not shown in my financial statement. And you are the seeds of the future. You are the seeds to make climate change differences. And so I applaud each and every one of you. Hats off. And I'm really, really grateful. Thank you.
Very well said. Me too. I'm really excited to work with all of you. I'm very proud of you, as I'm sure the whole university and half the universe in California is with all this cool work. So give yourselves a round of applause and thank you so much for the audience members, people like John and Ashley that have hung out with us and seen what these incredible students can do. Thank you so much. Have a great evening. Feel free to keep contacting me and I hope to see you in real life sometime soon.
Thanks, everyone.
Thanks.
Thank you.